Okay, hello everyone. Welcome to participate this session organized by the Research Metadata Schemas Working Group. I'm Ming Fang Wu. I'm working for Australia Research Data Commons. I'm co-chair of this working group together with Leila, Adam, and Salula. Unfortunately, they are not able to join today. So this session is about the guideline and the toolings for published structured metadata on the web. So just a few logistics and the session notes, and it's linked, and the link is available in the chat. So please fill in your attendances. All slides are made available, also linked from the collaboration, the session notes. And you probably has been already noticed this session is being recorded. So if you don't want to be recorded, please turn off your video and audio. And for any question and comments, please use the Zoom chat. Okay, so objective for this session is to introduce the group to members. Some maybe new, not heard this before. So we have a little bit of introduction. Also introduce the two outputs from the group, and we will have a showcase about the adoption use cases and the tooling as well. Then if we have a time, so we will start discussion on the topic about toolings for making the implementation structured metadata. Okay, with that objective in mind, we have an agenda for today, and so you will see we have 19 talks. Probably we would have just the 4. I'm not sure if Rebecca on this call. Anyway, so we will go to see how it goes. Okay, so I will give introduction to the group and group's output. So just a little bit history of the group. We started as a task force of the data discovery paradigm interest group. So we, at that time, we look at how we could repositories make their make their data more findable on the web. That was the motivation. So then after both sessions at RDA Plenary, we formalized a working group from P14 after 4 plenaries or about 2 years. That's the time time limit gave to a working group. At the plenary 16, we discussed the draft of output, and at the plenary 17, we have recommended output. Then P18 and 19, we basically discussed the adoption case. So as I said, we have 4 chairs, co-chairs of this working group, but we also have people on technical advisory board and a few people on this join this call. And most importantly, we have about 140 group members. Many of them are very actively contributed to the group's output, so we appreciate that very much. And And the group has regular calls. We used to every month, and since we delivered the output, and then we now transformed from working group to the maintenance working group. That means we have people to adopt the output or make amendment to the output. So now we have a meeting every 2 months. So why did we form this working group? So as I said earlier, we have people to publish, not we have, we look at the issue. People publish structured metadata on their web metadata web pages, so their data can be more findable by web search tools. As here is an example of structured metadata. So you have a normal metadata web pages like that one on the left, but within that HTML code of that web pages, you could add just a script and in the scripted section to tell what the to use vocabulary, from Schema.org or DCAT to describe your metadata in a machine accessible format. So any other web applications then can crawl those kind of metadata. And our first speaker presentation will talk a bit more about Schema.org, so I will not go to detail here. And with that drive, so the objective of this group is to improve data discovery by looking at a common way to publish structured metadata via Schema.org. And we would like to have this working group as a forum to bring together communities who are working on the same approach and bring them together to exchange experience. And through that, we can identify and bridge gaps in existing schemas commonly used for research data, and also provide guidelines for those communities whose needs are not addressed. For example, how to use Schema.org, but in combination with other external vocabulary external to Schema.org. So with that objective, we proposed 3 outputs for this working group. First, we look at the data models and trying to identify essential types and essential data types and properties for the data discovery on the web. Under that activity, we collected about 15 crossworks. That's one of outputs. The second output is we produce a guideline that provide end-to-end process, cover the end-to-end process of publish structured metadata. And also we tools are also important to make this process easier or possible. So we also collect some tools along the way. So that's a brief introduction of the group. So now I will introduce the group's output. So first one is recommended output. So RDA classify output type. Recommended ones, that means you need to demonstrate you already have adopter of this output. So for this guideline, as with 9 recommendations, as I said, cover end-to-end the process from scoping, what to be encoded in the markup to crossworks, to implement the syntactic encodings and the document and to the documentation and etc. So if you want to know more detail of these guidelines, so you can follow the DOI as in the previous slides. Yes, the slides, I just saw comment questions from the Zoom chat. The slides is made available now, is linked from the session notes. And the second outcome is the collection of crosswork. We call it supporting output in RDA terms because by the time we submit, we didn't find any adopters. After we publish that, finally, we find a lot. You will see from several presentations soon. So, so we collect a collection of 15 crossworks from from 15 source schemas to schema.org. So so we collected these crosswork. That means this crosswork were originally done by other people, not us, not people. Also, some of them are members of this group. But then we enriched this crosswork with about more terms added to that to enrich that crosswork. And also, Word Data System put the efforts, implemented visualization tools. That's very handy if you do your crosswork. If you have terms, you want to know how is mapped by others, you could use these tools to check out. So we align up these crossworks with mapped term in schema.org. We also classified those mapped terms by using metadata type that's from National Information Standard Organization. We classify them into descriptive metadata, administrative metadata, and structured metadata. So the number in the term here are the terms in property in schema.org. The number indicates how many source schemas are able to map to that term. So that we did analysis of this mapping. We found out that the descriptive metadata are mostly interoperable among the schemas that can be mapped into schema.org property. And the right metadata is mostly inconsistent. The terms like copyright holders, right statement, license, and that have multiple mappings into one. And the largest gap exists in structured metadata. That means the relationship between entities, and also lack of controlled vocabulary for specifying various property values. Okay, that was crosswork. For the tools to support that publishing process, we collect probably about 10 so far. We didn't have much time to spend effort on that. Now we have many people to show their toolings. Probably it's time we discuss about that. Okay, we hope that the output from this group would be benefit to research data infrastructures, in particular, for example, enhance interoperabilities across data catalogs. And this way to publish structured data could provide new methods to exchange metadata among the repositories, also enable federated search across repositories. Then we can support a spectrum of data search needs and develop a more innovative search system. Okay, that's the introduction to the group and to the output. We also want to get your feedback, so we have set up this Menti to get your feedback. We will have a discussion. We will come to this again. So you can go to your web browser, put in this URL, www.menti.com, enter this code, or you can scan this QR code from your mobile. Okay, next we will have 4 or 5 learning talks. So first we will go to the Polar Pilot Federated Search. This will be given by Melinda Minch. So let me stop sharing, and Melinda, would you able to share? Yes.
Yeah, thank you. There we go. Okay, hi everybody. My name is Melinda Minch. I work with the World Data System International Technology Office, along with Chantel Verhey, who is a more active member of the RDA. The way that we work together is that she does a lot of the community stuff and understanding the landscape of the polar research community and other research communities. And I do a lot of the web development stuff. And so that's why she's a familiar face to you, and I may not be necessarily. Unfortunately, she couldn't make it to this presentation, so you get me. So what are we doing here? What does our federated search app have to do with structured metadata? Schema.org is an activity to promote structured data on the internet, on web pages in particular, in order to allow web crawlers to look at a web page and know what it's about. And it also means that you can look at a data set online and know what it's about. And one way to do that is to use Google Dataset Search. So if you have a schema.org piece of metadata on your data set that's in a JSON LD format, you can have a title and a description tag, and then Google Dataset Search can find your data set, it can index your data set, and other people can find it. And that's pretty cool. So if you are able to find data sets online. And you can search for them using titles and descriptions. What happens when you want to search for them using keywords, or you want to search across a specific domain, like the polar research community? So the Polder Working Group asked this question. It's a collaboration between the Southern Ocean Observing System, the Arctic Data Committee, the Standing Committee on Antarctic Data Management, and they've been working on getting a federated search going for the polar research community because Google Dataset Search doesn't always do what they want. So if you have just a title and description, that's cool. But if you have a much more rich set of schema.org metadata, like the set that scienceonschema.org espouses, then you can search on things like authors and keywords and timelines of when the data was collected and even where the data was collected. So by espousing the best practices that schema.org or SOSO puts forward, we can build something that is able to search data sets that adopt these metadata standards. Because if it's not in the metadata, you can't really search for it. You have to be able to get a piece of data that has a date on it in order to search using a date. At this time, it's good to know, for you all to know what a federated search is. So a federated search is when you make a request on a single website, you have one search box, and that site goes out and searches all kinds of different data repositories. And it compiles the results on a single page for you to look at. So you don't have to go to BAS and CCHDO and a bunch of other ones to try and find your data set. Hopefully you can just go to one and it will be right here. So a little bit more on the Science on Schema cluster that's done through ESIP, which is Earth Science Information Partners. They've been working for quite a while on providing guidance on how to make up schema.org metadata for the earth sciences. They have just released version 1.3 actually, which includes recommendations on new terms like, oh, what's in there? I think there's some temporal coverage stuff that's in there that's new. And you can participate in these. So if you are excited about defining metadata standards for the earth science community, you can tune in and help out. So what does this have to do with the federated search guidelines? Basically what we've done is taken the scienceonschema.org guidelines and said, okay, we are really, really interested in a subset of these that are very important to this community. And so we produced guidelines for that polar research community that say, if you include these terms in your metadata, we will be able to pick you up and work with you. So Polder provides mandatory, recommended, and optional terms for the metadata. We use polar specific examples in our recommendations, and we're still working on it. And that's the difference. So what do we say people need? We're saying that we need things like an identifier. We need a license. We need temporal coverage. We need spatial coverage. And why do people want a federated search? Again, you can go to one website and find it instead of searching a whole bunch of different repositories. It seems that it takes about a day of developer time to complete the schema.org markup. That's if you have an automated way of marking up your web pages and your data sets. And if someday the Polder federated search goes away, because it's built on schema.org, you would still be indexed by Google Dataset Search. So now we're going to do a demo because that seems pretty fun. So I'll take you over to search.polder.info. This is the live site. I'm going to make a search for bioturbation, which is the process of seafloor sediment getting disturbed by animals, if you didn't know that. I'm going to make some typos. Let's see, so we want to search for data sets when the data was collected starting in 2015 or after and ending before 2020, just because why not? Press the search button and you have some data. So you can see this one is a data 1 data set. The search goes out and queries data 1's index. So if you are in data 1, you are in the search. And it also uses Gleaner, written by the fabulous Doug Phils, to index repositories that don't necessarily want to be in data 1. So here's one. I think that's also a data 1 one. And you can see, yep, there's the British Antarctic Survey. So you can link out to landing pages. We expose DOIs when we can get them easily. And we're still working on this all the time. See, what else can I say? I'll talk to you about the infrastructure here. So this is a Python app built in Flask. You saw the user interface. It's a web page. It sits inside of a Kubernetes deployment. And what the app does is it says, hey, Gleaner, go index these repositories that we want to know about. Gleaner goes and does it and puts it in the triple store that's specific to the federated search. And so when somebody makes a query, then the federated search asks both the triple store and data 1 those questions that the person wants to know and comes back with results all in one place. So here is our great big list of repositories. We're hoping to get StCaddy in soon. We've got quite a few through data 1 already, and we're indexing people who aren't in there all the time. So we just got CCHDO pretty recently, which is cool. How do you get in here? So the first one is, again, if you're in data 1, you're in here. Congratulations. The second one is, if you can follow the SOSO guidelines or the Polder best practices to mark up your existing metadata structure, then you just give us a sitemap link and we can go out with Gleaner and index you and you're in. The third option is if you aren't able to do that or you don't have the capacity to complete that, we are going to try and help you out. So we would like to help you figure out how you can get there or how we can meet you where you're at in order to be included. So next steps. We have a new co-op student who joined us back in April. Welcome, Yumisi. He's on this call and he's been putting features into production. So that show more button is from him. Pretty cool. We've got some KPIs in the works. So we want to do some things like tracking of unique site visitors and do some instrumentation of the site to help us figure out how our relevance ranking is doing. I attended the Joined Up Scientific Data Discovery session earlier, and I got a lot of cool ideas from there. I have a lot of reading to do now from all of you, so thanks for that. We're working on spatial search, indexing more repositories, and we need to find the next host for this app. Data 1 is graciously hosting us for now. Maybe someone else will host the production infrastructure in the future. We've made it pretty portable and just intentionally so that it can live in a variety of places. Yeah, if you have more questions, we'll be presenting again at the World Data System Community Day tomorrow, or you can email me or Chantel or sign up for our mailing list. Thank you very much.
Thank you, Melinda. That's a great presentation to explain schema.org, the approach and the benefit, and thank you. I don't think the speaker for second scheduled talk in this course, so we will skip that. We go to our next presentation. Brian, that would be you talking about common metadata framework.
Okay, thank you. So we have been working with other crosswalks from the Research Data Alliance and have been exploring how to extend those crosswalks to mobilize computable biomedical knowledge. So I will introduce why our focus is in the area of biomedical knowledge and things we're doing that have been outside of RDA related to this similar area of crosswalks and mobilizing the data through the metadata. So to give you a little bit of background introduction, because these may all be new organizations to you, in the community of healthcare, Health Level 7 International, or HL7, is the standards developing organization, similar in some ways to RDA. And one of the standards they've produced is called FHIR, Fast Healthcare Interoperability Resources, and it is widely used as a standard for health data exchange, exchanging the data from electronic medical records in many different ways. Another consortium is the Mobilizing Computable Biomedical Knowledge, or MCBK consortium, which is focused on activities based on its name. Along the way, I have done a lot in the area of clinical decision support and evidence-based medicine. And several years ago, took on the mission of enabling standard-based machine interpretable expression of public knowledge, especially related to healthcare and scientific evidence, and have started a EBM on FHIR project, extending FHIR designed for health data exchange to evidence-based medicine, or exchange of the scientific evidence and guidance from scientific evidence for healthcare. When COVID came, we created the COVID Knowledge Accelerator, which is an open virtual group now meeting 12 times every week, doing many different activities. And then a Scientific Knowledge Accelerator Foundation is a nonprofit organization to facilitate virtual scientific knowledge accelerator groups. And I started a small company, Computable Publishing LLC, which has produced a platform like FHIR, but replace health with evidence. So it's FEVER, Fast Evidence Interoperability Resources, as a platform to host interoperable data exchange for scientific evidence. So as a thought question, what if we had a universal translator for structured data? How would it work, and how do we build it? So the common metadata framework you can think of as a generic schema or data structure to represent a transfer point between the database schemas or data structures, in a crosswalk. And in some ways, it sounds like schema.org may be a good model to look at as a model for the common metadata framework. So here is a general image to explain if we have 7 different database schemas and we want to convert data from any one of these schemas like RIS and get that into another schema like FHIR, we would need one conversion tool for one direction, one if we wanted to go the other way. And if we wanted to do that for every combination here, it would take 42 different crosswalk paths or conversions to make it happen. If we had a common metadata framework, then it would take 14, as each one of these could create one back and forth pathway and then exchange across the others. So as an example, in RIS, it's a very simple format, and A2 is the element name, and John Smith here, A2 means secondary author. The problem is there's too much reliance on knowing exactly what A2 means to understand the meaning of this data value John Smith, and there's only so many ways you can combine things with 2-character element names in this form. But that's one example of a data structure that is very commonly used for citation data. FHIR has a citation resource represented in JSON, and within the citation resource, there's a cited artifact element, and within that, there's a contributorship element, and within that, you can have any number of entry instances in the entry element. And to handle the same concept, John Smith is a secondary author, we would have a contributor element, which has many ways of referencing the contributor. And in this example, the display element finally gives us the name John Smith. And the concept of secondary author is a role element, which has a coding with a code system that we can look up for the specific code author. But then the code system doesn't have a code for secondary author. So we also have text here to add the additional secondary author. Now, this could be a problem in the other direction. This may be too complex in requirements to use across many schemas if you're trying to transfer between, the other systems. So in the common metadata framework that we're setting up to represent this, we have an element at the higher level for an object of contribution, and it contains agent. An agent could contain who. Again, you can represent in different ways. In this example, the label is John Smith. The agent can have a role, which is author, and then a related role for many of these subsidiary or related roles, which in this case is secondary author. Is this an optimizing solution? Finding the balance between simplicity and complexity, providing just enough detail to be able to map to and from these other schemas. So we have spent a year categorizing metadata to help with the findability, accessibility, interoperability, reusability, and trustability of the data, and published from the MCBK effort 13 categories of metadata to do this. And then we set about specifying the metadata in a common metadata framework. And along the way, we discovered several crosswalks from RDA and mapped all of the items, 800 rows of elements and about 20 or so different metadata schemes in these crosswalks to the common metadata framework. And in doing so, adapted and learned how to change things in the common metadata framework, especially as you noted, Mingfeng, earlier, the related artifact, the relations between resources needs a fair amount of help. So we developed a pretty robust structure for how to organize the many different types of relations and a set of terms or code system for the type of relation instead of making a separate element for each one. So our common metadata framework has 146 total elements now, and these are the top level elements organized by different major reasons for that, for its use. So to learn more, there is this link on the Fever platform for the project for the Common Metadata Framework project, where you can learn more about this specific project. Another link here for the COVID Knowledge Accelerator. And the Common Metadata Framework Working Group meets weekly on Tuesdays at 11 a.m. Eastern Time. And here's my email address, and I can put this in the chat as well if you have any questions and want to follow up on this. Okay, I think you're on mute, Mingfeng.
Sorry. Thank you for the presentation. And certainly have a common metadata framework will reduce many redundant crossworks. So if you have any question and comments, please put in chat. We finish 2 more presentations, then we can come back to your question and comments. So we move to our third presentation. That is about Tobias. Is your turn. So Tobias will show a mapping process for RDF data from different data models to schema.org.
Yeah, thank you very much. Can you hear me fine? Can you see my screen?
Yeah, all good.
Oh, perfect. Okay. So I'd like to present my work on mapping RDF data from different sources to schema.org. So we have a project whose aim it is to build a knowledge graph with open research data. And there's a lot of RDF data sources that would like to integrate. And now we need a process for this integration. So it's there's some things you want to consider. So it should be a declarative process. So it should be as transparent as possible, also for documentation purposes. The process should be configurable. It should be flexible. So we should be able to add new data fields that we would like to consider. It should scale for a lot of sources. It should be comparable to RML, the RDF mapping language, which is for non-RDF sources. So we want to have processes that are quite similar for both RDF and non-RDF sources. And I mean, we wouldn't like to reinvent existing things. So this is why we chose Sparkle, because it's a standard. So what are Sparkle construct queries? So whoever uses Sparkle is maybe familiar with select queries. So Sparkle select queries, they return tabular data, like it is the case for SQL queries, or if you deal with CSV files. And construct queries are a different type of queries that are returning RDF triples. So it returns another graph. You query a graph, and what you get back is a graph as well. And so in our case, when we use it for mapping, you can think of it as a thing that a query that takes a source data graph as an input using some custom ontology, and what it returns is a transformed graph, which is in your target ontology. In our case, that will be schema.org. And a construct query has 2 parts. So there's the where clause, which matches the source data, and you have the construct clause, which defines the target graph. And by the means of Sparkle variables, you can actually transform data from one graph to the other. So let's look at a very simple query. So here you can see, let's try to use this laser pointer. Here you can see a very simple query. You have the where clause, which is here. You can see that the source graph is a friend of a friend person with a first and last name. So you have a variable which is bound to the IRI of this person, and you have 2 other variables which are bound to the first and the last name. And now you can use these variables to rewrite friend of a friend to schema.org. So the friend of a friend person becomes a schema person, and the friend of a friend first name and last name become schema, a given name and family name, using the same variables. It's totally arbitrary how you spell those variables. It's just important that you reuse the same ones. So whoever is familiar with Python will be able to read this. So here we're using REFLib. So we are just taking some sample input, a simplified JSON-LE, which represents the person in friend of a friend, John Doe. Then we construct an RDF-lib graph, load this data in, apply the query, which I've seen before, and the result of the query is the same information in schema.org. So this is how we map from the source ontology to schema.org. Put in a more graphical way, you can think of it like this. You have the source graph, which you just project to schema.org. So in this case, it's very simple. It has the same structure, but in theory, you can also reshape the graph. I wouldn't recommend the use of too many Sparkle functions, as this is a bit confusing sometimes. But in theory, you can reshape the graph in some way. So we have different use cases. So we have a use case from the cultural heritage domain. In this case, there's a REST API where we can fetch JSON LD files. They contain a bunch of related records like a video or audio file which is described, and persons who created this content, persons who are mentioned. We have different source schemas like resources in context, which is used for archiving, DC terms, and so on. And now we are using the process which I've shown before. We just load this data in RDFLib, apply the Sparkle query, and get the result in schema.org. So in this case, you have quite a lot of small files. So this is just a process that processes each of these files, which can take some time, but it's actually quite easy to deploy. We have a second use case, which is from data curation. The workflow is very similar. We just have different source ontologies. Here we have things that are already in schema.org. It's a mixture of schema.org, prof.o, and some custom entities. And we have a third use case, Europeana, which is again about cultural heritage, where you have like the Europeana data model, EBICOR, DC terms, and so on. So technically, these work all the same way. It's just that you write different Sparkle queries for each one of them. So what are the advantages? So the advantages are that Sparkle, of course, is a standard. So there are various implementations available. So if you don't want to use RDFLib because it becomes too slow, we can choose another solution. It should work the same way, at least in theory. Yes, Sparkle queries are declarative. So the whole process is transparent and it's kind of documents itself, of course, if you know Sparkle. So the whole approach is based on RDF. It's not a particular serialization of RDF. So you can use JSON-LE, but you don't have to. But there's also some limitations. So these queries can get very slow. Also, if it works, you might have to optimize it in several iterations, and your queries can get quite complex. And I found post-processing to be necessary in most of the cases. So sometimes you need to normalize things, and it's hard to do it with Sparkle functions. And you have to standardize things as well. So what could be the future steps? I would really like to find a way to derive these queries from the RDA crosswalks. So we had a presentation in our meetings about LinkML, link markup language, which puts spreadsheets in some structured machine readable form. So maybe that's a way to go. Let's see. And I would really like to do some kind of benchmark. So I would like to use different Spark limitations or engines and compare them for a given data set and a given query. So yeah, that's it. Thank you very much.
Thank you, Tobias, for your presentation. And Tobias present at 2 a.m. from his local time here, so much appreciated. And Tobias' presentation shown us, apart from keyword queries, we can send a semantic queries with structured and then linked metadata. Thank you. And we have a last presentation from Lindsay.
Yep.
Yeah.
Hi. Okay. I will share my screen. Okay. Is that coming through?
Yes. All good.
Okay.
Yeah.
That's
Thank
good.
you. Yeah.
Okay. So I'm glad I actually went next because this kind of follows up on in a different way of all the things that people have been doing kind of in developments across RDA. So, oh, sorry. So people who aren't familiar with the National Lab, I have no idea what is going on. Osary. Okay, sorry about that. This might be okay. So those not familiar with the National Labs, we have 19 total, and they're all very, very diverse, and they all have a unique set of capabilities. So our lab in particular is really unique. I think it's not just energy, there's a lot of applications and technologies. We all kind of have our special skill at all the labs. And so my focus is sort of, what are we doing with schemas behind the scenes and making knowledgeable connections with data and objects, and how are we transforming how we're making relationships as we go forward and building new insights from existing data or auto capture data. So Pnl Data Hub is a institutional repository that we have, and so it's very flexible in the sense of the data model schema. So all of the schemas in the crosswalks we accept, use, and can integrate with. So there's a couple systems on the back end how we use those. And so with the crosswalks, my interest is in extending them. So these are some great concepts that already exist. This is fantastic publication by a group using some semantics to connect project deliverable outputs, and how do you find them, and how do you define them, how do you categorize them? So this is EDAM. It's one of my favorite ontologies, actually, very flexible. It's great for operations applications and finding really nice complementary relationships. So this kind of leads into the tooling. So as there's some gaps in some of these schemas, and not all of them are going to capture these high throughput instrument details, these records. So ontologies are a way to expand upon those in the time being, and tools are a way to capture those edits so that you can maximize collaboration, but also have that transparent record as well. So this is an example of an instrument we use. There's a lot of details about it. There is a method taxonomy. There are topic areas of interest, who can apply these regardless of what you do. And a lot of it, centers around what standards connect to them, because a lot of the way that we structure our data and the operations in which we query them to build new insights are really, really dependent on the data model schema and the standard ontologies as well, and amongst other things. So this is a good case use of fair sharing. I do curate there for omics, and it's been invaluable because it's such a quick and easy way to understand what you need to do with your data and how you need to prepare it to collaborate with someone who might not have the same model schema, but you want to be able to build something or integrate across platforms. So this is that high level. This is integrating some of the work that, you know, the FAIR digital object framework goes with, you know, like how do we put those into place? How does it make sense to a user versus a developer? And then in the community with machine, you know, actionability, we want to be able to not constrain the types of language we can use in a developer's platform, but be flexible with the ontology as well. And sometimes that depends on what schema maybe a collaborator uses or what languages are even available. So of these, of course, there's a bunch captured in there, and a lot of the concepts already discussed. So Protege, I think some people are familiar with it. I'm a favorite of it for a couple of reasons. I don't use it for visualizations. Actually, I use it for its ability to version, import, export, build on ontologies in a structured way, and be able to collaborate, even if there's you know, challenges with spoken language or programmable languages. It's very flexible. You can integrate it with a lot of plugins as well, and it's open source, it's free. So, you know, you can also collaborate on the web. They have a desktop and a web version. So it's really great for spaces like, for example, you know, if you have experts building machines that don't have ontologies yet, how do you extend that language to describe how it's collecting the data? Because if you don't know how the data is collected, how would you know to you know, query and combine it actually? So here's a good example of, no matter how you format it, you can import CSVs in here, you name it, JSONs, all sorts of multiple ontologies, and then merge them into one and then export it in a format that works for you or your collaborators or your platform. So this is a good example of, you know, the mass spec language has, you know, a controlled vocabulary by the, you know, the proteomics standard initiative. So being able to structure an instrument that is a hybrid of something that maybe their ontology doesn't even cover, and then be able to define it as it's a device, it has a measurement technique. These are all things that are defined also in like schema, like a lot of things that people will use. So this is a way that I see you can adopt some of the standards from groups coming out. And this is a way to, you know, collaborate, even if someone's not a developer expert. And of course, there's not a one tool fits all. So this just kind of just depends on what you're after. And this is a way to put it all together. So here you have your schema.org, you know, metadata schemas, but then you also have different languages and different standards, and you have to be able to create constructive connections across those in a way that a machine can find, but that there's so many details involved, right? So, you know, this might be a technique, but it has multiple outputs. And the thing that, you know, you continue to see is a lot of these outputs are missing in publications. So can you make intelligent connections where if you couldn't find the journal article, could you find the data? Would it make sense? Can you reuse it? Because, you know, in the world of instrumentation, you know, you have a whole family of mass spectrometers, but they don't do all the same things, and you can't compare data outputs unless they're collected on a similar instrument. It's and that's something you would never know unless it was organized in a way with the data model schema set up in this way, and then also having flexibility with language. So that's something that I see. To point this out, actually, two newer outputs is these are the persistent identifier for instruments. They are a newer group. That's something where, you know, these are all JSON LD formats that you can link up. You can link them back to citations, processes, and this kind of expands what we can do with the data when we have these standards in place. Oh, and I also have the FAIR for RS over here as well. So, you know, are we capturing how we're transforming the data before we're interpreting it, before we're using it? So that's kind of some developments I've been working on, and there's a couple more outputs that will be coming out from that. And with that, that's all I got. Thank you.
Thank you, Nancy, for your presentation, and thank you for all speakers. So for presentation, just to give a snapshot what we could possibly do with structured metadata markup and crossworks. If you want to know more detail from each presentation, you could contact the speakers, or there are more interest, we could organize a detailed talk in our regular group course. Yeah, just you can put show you any interest in the session notes if you want to hear more. And are there any questions about any of those presentations? Now is a discussion time, and Lindsay, do you want me share could you please share that Menti? Let me see.
Yes, let me pull.
Yeah, so Lindsay kindly set up this Menti for us. So yes, Brian put the URL and the code to enter into the Menti, and if you could, participate, that would be great. Let me find the link as well.
Sorry, I was just taking a.
I found the link, Lindsay. I can share if you want to. Lindsay, you're on mute if you have spoken.
Yeah, no, that's fine. Sorry about that.
Yeah. Okay, no worries. I found the link. I can share my screen. So first questions is what are 5 keywords that you can describe your area of expertise, interest, and curiosity related to research metadata on the web? Has everyone able to get on the Menti? When I share screen, I don't see people. Let me have a chat. That's a difficult one. So we have a word T, have a letter T so far. And then Lindsay, is this the simultaneous report?
No, I don't believe so.
So I got the wrong link. sorry, to bear with us.
Okay.
Maybe you share from your side.
Yes, 1 second. Sorry about.
Sorry, I missed the wrong URL. That probably was for testing.
Sorry, 1 second.
Okay. So meanwhile, has anyone on this call, you know, I'm not sure which role you play in your organization or from data repositories or data libraries. Has anyone have experience of implementing this structured metadata markup in schema.org? Or is anyone interested in implementing? Annalena, so
Yeah,
you have your
hi.
hands up.
Yeah. Yeah, hi. I'm kind of research and we're very much interested in. Well, so far we are harvesting data in XML, but the road to go clearly is harvesting triples. And so far we have made first attempts to map our metadata schema to DCAT. But I'm still learning, so I'm not sure for research data which standard to use, like DCAT or Schema.org. I have to read up which one is better suited. And yeah, I'm learning happily here.
You are modest. I'm
no,
sure B2 does well, so yeah.
Yeah, and yeah, for us the complicated technical implementation. I will say we are only a small team, everything with 2 persons.
Oh.
So we don't have much tech support there, but yeah, I'm curious, and I've learned a lot in this session already. Thank you.
Thank you. And we can talk offline how we can, you know, adopt or something like that. Lindsay is ready to share the Menti. Lindsay, do you hear me?
Yeah, I hope so.
Yeah.
If it's not working, I'm sure someone here knows how to do it. I don't know why it's so challenging this time around. Makes sense. That always happens. Okay, so here are 5. Yeah, now
cool.
It's time to populate again.
So, okay, so.
And then I want to say, I'll just keep going through this. Yeah, might be the first time. Okay. Oh, yeah.
So,
there we go.
Yeah. So
yes.
let's is that possible we go back to look at what the 5 words people describe? Yeah.
I think it just keeps going for a little bit.
Oh, okay, that's good. But the creative and stands out, and that's great. We have a bunch of creative people. Cool.
All right.
And the leaders and the fast, yeah, and focused. That's great.
Could those be maybe examples?
I don't
And Woma said probably not all words shown up. Probably Woma, if you put one word, probably I'm not sure if just.
It's a good question.
Yeah.
Like if no one put anything, what happens?
Okay, thanks. Let's move to the next one. So have you currently involved in any metadata repository effort publishing structured metadata on the web? So we have, so it's up and down, the numbers. So, but we already have 30% of on the core implemented and 23% in progress. And we have people not implemented, and we also have category learning more.
Right.
That's a lot of feedback.
It shows 100 and some votes, and it says on the right side showing test votes. So I think we're looking at some sample of how to use Menti instead of the actual data.
I don't.
Oh,
How would that work?
I
uh,
don't,
okay. That's why people
Well,
say
and the code at the top is not the same code that we put in.
okay. So
oh yeah, they're different from the. I think they're different from the backside. I want to say. Well,
Now there's only one entry.
Yeah, well, maybe this is maybe we come back to this. I can export results at least. That's helpful. Would that be more helpful probably? I'm not quite sure what's happening with this.
okay.
Yeah, you can export results as PDFs.
Yeah. I've never had this much trouble with this before. It's interesting.
Well, we're not sharing a common form to make this interoperable for how to share our ideas.
Yeah, right? It makes us human. Okay.
Yeah. Okay. So while we're still working on the Menti, so there is a comment in the chat, Doug pointed out that in US, the Earthcube geocodex is also working in these directions. Doug, do you want to give a few words about that? Introduce that what kind of works be done there?
Sure,
Sorry to put you on spot. No. I'm trying to find the Menti link.
No worries. I'll fill some time for you while you do that. No, in the US, the geocodes is an Earthcube project. It's a continuation of some of the early work that was done related to schema.org and publishing them. So the upshot is there's about a dozen, or actually I think there's probably closer to 20 now, research facilities in the United States. Most of them are NSF funded. There's a few others, but most are NSF funded, that are publishing schema.org about type data set. And then we collect that information, right? So standard web architectural type patterns. They're also part of the Google dataset search. And that's one of the wonderful things about this, right? Is there is no, preferred indexer in this regard. Once they publish that information, anyone can use it. And so those indexes then are being generated, and we have a user interface then that allows you to search over that graph. And yeah, so I put in a link there to geocode. It's all open source work, so you can see the user interface and everything like that. Also, then the UN Ocean Info Hub is also using this pattern as well. So, I mean, it's a really kind of fun ecosystem to be in, right? You've got CCADI, you've got Polder, that were presented here by Melinda. And, so it is nice that there is this kind of community of people who are now realizing that, hey, we can build our own search interface for our community. And in reality, as a community, we can also build our own knowledge graph, right? And that knowledge graph becomes then a shareable product amongst the community that they can also leverage in their local environments as well.
Thanks, Doug. Sorry, I'm busy to the Menti link. I think Lindsay, the link I got don't have the results. Probably the wrong link. Anyway, so so has anyone there have developing any tools to support the the mapping and or have done any cross work, not necessarily to the schema.org, but cross work to others, from one standard to another, if that come close to the come across, you know, to the crosswork we collected, probably we could take your crosswork then to look at how that mapped to schema.org.
Yeah, and this is Doug again. I might just kind of throw
Yeah.
out there's. I was really interested in the presentation on Sparkle and using that and their Sparkle constructs, right? So I mean, it's kind of like it's one of those things where it's kind of like, oh yeah, Sparkle construct. It's kind of like, but then when you see someone do it, it's like, yeah, I should look into that. There are also some nice work that's been done by Steve Richards in using XSLT to convert from ISO formats, especially like the 119 type formats, into schema.org. So you're crosswalking from XML into schema.org, JSON LD land. And then also you can do things with Shackle AF. So Shackle Advanced Features allows you to essentially do a shackle test and then fire off a Sparkle construct, right? That would then generate out the triples as well. So it's really interesting to see the presentation today with Sparkle construct, and then think about it in terms of Shackle AF with Sparkle constructs embedded in the shackle shapes then.
Yeah, I think that the presentation of Sparkle is also good because we keep thinking how to organize the content, but haven't demonstrated what the benefit, what the usage. If we could demonstrate more usage side or benefit, probably that could motivate people and come back to adopt this kind of approach.
I think one actually, just to kind of throw out an idea for the group there, is that if you took something like that, whether it be the Sparkle construct or a shackle or something like that, it would be fun to throw that in something like a GitHub Actions, right? So that someone takes a file and you know that they have a DCAT in it or something like that, right? You throw that into a repo, GitHub Actions fires off, performs some of the code like we saw today with the Sparkle construct and generates out a new RDF graph then in an output directory in that GitHub. That's really cool, right? Because now you got a situation where people can publish their DCAT RDF, just essentially do a git push, and then have some actions fired off that then construct it into a wholly different, vocabulary environment, right? So it's a whole new graph. So that would be really cool, I think, and a useful demonstration.
Yeah. So that kind of Sparkle, query has been there and proposed for a long time, and also Toby said, performance is an issue. I haven't been, look at it for a while. Is that it has been an issue before? Is it still an issue today? Compare, to in Tobias' presentation said that you need to do some pre-processing, to make it work. While if you do keyword search, you can, pretty much you can index dynamically and constantly. Then it's index fresh, very quickly. So how does that compare to Spark query? Tobias, do you have any comments?
Yes, I mean the infrastructure we're using, it offers both Sparkle and the Elasticsearch. So it keeps the data in sync into different databases. And I mean, whenever it comes to text search, we're using Elasticsearch, which is very powerful, very fast. And if you want to do some, like deep graph search, like the structure, then you use Sparkle. But I mean, also now with very small data sets, a Sparkle query or this transformation that I showed can get very slow quite quickly. I mean, sometimes it feels like black magic optimizing a Sparkle query. It's not always clear what you have to do. I developed something with unions. You just combine unions, or you can even nest them, avoid optional clauses. This seems to make Sparkle slow. I mean, sometimes it also depends on the engine you're using. I mean, it might be fine with one triple store and it's really slow in another one. So sometimes it's not very clear. Although it's a spec and it's a standard, the implementations still matter at some point.
Yeah.
I find, yeah, sorry, go ahead.
Sorry, Melinda, go ahead.
Okay, yeah, I was just going to say that I find that that's been my experience as well. The Polder Federated search does a big Sparkle query to get the results out of Gleaner's triple store. And I've been finding similar things about, you know, things like optional clauses and unions do tend to slow things down quite a bit. And I have been comparing a couple of different triple stores, and it is very different what will slow them down. And the performance of them is very different in general. It's interesting too, because people have lots of different ways of implementing schema.org metadata standards. And so even though there's a standard, there are a lot of different ways to interpret the standard and a lot of different options in this standard, in the SOSO standard. And so I find that I have to write queries that are kind of broad and look for a lot of different things in a lot of different places. So it might be interesting for me to do a little reshaping in the way that Tobias presented in order to try and cut down on that too.
Thank you. And on the other hand, I think it's a very powerful query and language, because recently when I interview researchers, the almost all of them complain there are too many search results, where to go. So I guess that the Spark query would, you know, you will be deliver more accurate search result to users.
So is anyone connecting their Sparkle queries to analytics, out of curiosity?
Do you mean like to measure the performance of the triple store, or what exactly?
Yeah, pretty much.
I'm not really doing it in that formal of a way. Because it's almost the same query every time. It's like structured in a way where you take sort of the person's search term that they put in and maybe some dates. I'm doing it in a more informal way, where I say, okay, if I move this up here, now does it take, you know, 0.5 seconds instead of 1? It's much less benchmarked than that.
Okay, sorry, we haven't get Minty online, but we will post the results. There are a few people participate, and Lindsay is set online for a while, so we after that we can put the result in the session notes. Yeah. So we can only.
Yeah, it'll be open longer. Sorry.
Okay.
I'll make sure to push it out more. Yeah.
Thank you,
Sorry
Lindsay.
about that.
No worries. And we pretty much cover in the conversation, you know, who is doing what, and we almost finished. Does anyone want to give last minute comment?
I'll just say thanks for all the great presentations. It was a really wonderful session.
Yeah, so that's I'm so grateful. You know, we have for voluntary speakers, you know, and also for Lindsay and Chantel is not here today to help organize this meeting, and we also see Julia and Doug. They are also very active member of this group, and thank you very much for your support, and thank all speakers and all people participated today. We will keep in touch, and you are welcome to join our regular course. We usually send the meeting reminder a couple of days to the group's mailing list. If you are interested, if you are already a member, you can find our group and just sign up. And I'm not sure that one in Dog Hold will sign up for our group as well. Okay. Okay. Thank you, and thank you very much. And yeah, and see you in future sessions. Bye.